Hi all, this is Lakshmi working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the topic feedback amplifiers in the subject analog electronic circuits. So the term feedback is first introduced by Harold Black. So he's an engineer in Western Electric Company. So normally the feedback is used in all amplifier system. So the purpose of the feedback is to stabilize the gain of the amplifier for use in various applications. So feedback means a part of the output is taken and is again fed back to the input. So that is called as feedback. So this type of feedback system will stabilize the gain of the amplifiers and also makes the system noise free and interference free. So as I told, so this is the general block of the feedback amplifier. So here it is a technique where the proportion of the output is taken and is given to the input. So output is taken and fed back to input. So this is the amplifier section and this is the feedback part. So here beta is called as feedback transfer ratio. So it is recombined with the input. And there are two types of feedback. One is positive and the other one is negative. Positive feedback means the feedback signal and the input signal will be in phase. So that is the input signal and the feedback signal are added and given to the amplifier section. Whereas in negative feedback, the input signal and this feedback signal will be out of phase. So the signal is subtracted from the input and is given to the amplifier section. So this is the positive feedback. So this type of feedback is used in oscillator and other application. So one real-time example of this kind of system is the public audio system. So here when you bring your microphone near to the loudspeaker, you will get some uncontrollably loud noise which is unpleasant to us. So that is due to the feedback, right? This is one example of positive feedback. And the next is negative feedback. So as I told, the output here is subtracted from the input. So this negative feedback is used in all kinds of amplifiers. So one real-time example where this negative feedback is used are the speed control. Here, if the car starts to speed up above the desired set speed, then the negative feedback will cause the throttle to close, such that the reducing the speed. Similarly, if the car slows down, this negative feedback acts to open the throttle. So this is another example of the negative feedback. So this is the general block diagram of the feedback amplifier. So here we can see the signal source, the basic amplifier, the feedback network and our output, that is external load. So there are two blocks extra here. One is between our signal source and the feedback network. We have a comparator or mixer network. Similarly, between the output, that is our external load, and the feedback network, so we have a sampling network. So the purpose of this comparator or the mixer network is that it will combine the input signal and the feedback signal, that is which is taken from the output is fed back to the input. So the purpose of this mixer is mixing up the signal source and feedback signal. And the purpose of the sampling network here is that which part of the output has to be taken and fed back. So that is done by this sampling network. So we have series and shunt mixing as well as sampling. So advantages of negative feedback is that the gain sensitivity, that is variation in gain can be reduced. Then bandwidth extension, noise sensitivity, reduction of nonlinear distortion, and we can control the impedance level. That is the input and output impedances can be increased or decreased. Disadvantages of negative feedback is that the overall amplifier gain is reduced compared to that of the basic amplifier. And the stability, there is a possibility that the system might become unstable and it might oscillate at high frequency. So as we know that no such any system can be completely stable. So there is a possibility of instability where the amplifier would oscillate at high frequency. So classification, so based upon the mixer part and sampling part, there are four categories. One is a voltage amplifier, current amplifier, transconductance amplifier, and transresistance amplifier. So we have series shunt, shunt series, series, and shunt. So this is the general diagram for a series shunt, shunt series, and series, and shunt feedback topology. So in series shunt, you can see that the voltage signal here is given in shunt connection, whereas in the output, the voltage is taken as series. So this part, series, indicates the sampling network, and this part indicates the mixing network. So if this kind of connection is done, it is series shunt. When we go with the shunt series, you have the current as the source, and here you can see the series mixing. So this part, and here the shunt parallel connection is done. Similarly, for series, the voltage is taken here. So the series type of mixing and the series type of sampling is done. Here the sampling is shunt, and this mixing is also shunt. You can see the current source here. These are the four categories of feedback topologies. So the assessment for today's session is examine the need of feedback in BJT amplifier. So as we have discussed, introducing feedback in the circuit will stabilize the gain. We can adjust the gain of the circuit. We can make the system noise free, distortion less, and interference free. So thank you.